Hello everyone, thank you for watching the video. I'm Paul Penn from Tech. In this video, let's prove theorem 2.2, the rank theorem. The rank theorem says if A is the coefficient matrix of a linear system, we have n variables. If the system is consistent, then the number of free variables give us how we can find the number of free variable using rank. It says equals n minus the rank. Okay. See, the number of free variables is linked by the rank. Okay. Is this true? Yeah, it is a simple one. Let's look at a proof. So what is the number of free variable? Okay. So number of free variable, do you believe this? Number of free variable. So we have two type of variable, okay, in a linear system. One is a leading variable, another is a free variable, okay, right? So that's the definition. And the total number of the variables is determined by how many columns in the coefficient. So therefore equals the number of total variables, okay. Variables minus the number of leading variable, right? So we have two types. Okay, one is a free variable, one is called a leading variable, and the sum is the total variables or the variables. Or the variable is determined by n. It says n, okay, n variables. So therefore, so this equals n. The number of total variable is n. The number of leading variable is the number of leading variable. Okay, so that's one is exactly the rank of A. So we done. Why the number of leading variable, okay, equals the rank of A? You see. Because leading variable, it can tell you how many leading ones, okay. The rank is how many number of leading one, because the rank of a matrix equals the number of leading ones, okay. And the leading ones is the same number of leading variables, okay. So we don't. Let me give an example. Give an example. If a matrix go row operation, and see. So we have R, reduce the row echelon, or row echelon, doesn't matter. Okay, for example, there's a 1, 2, 3, 0, 4, and then 1, 1, 0, 0. Okay, so that's all ones, okay. Let's see. Something like this. So therefore, so n equals A is the coefficient. So here is the total variable, right? Okay, so therefore n is the column of the coefficient matrix. N is, no, not a 4, it's a 5. 5 columns. Okay, that's the number of total variable. Do you believe this leading one or leading entry? Okay, whatever. If this is a reduced ratio, if this is not a reduced ratio, and this one probably will not be one. That's called a leading entry, but it's the same. Okay, leading entry can go to leading one. So now we have two leading one, right? So from here we get two leading ones. Means what? Means two leading variables. Okay, that's two leading variables. Therefore, see, here we have three free variables. So how we can get a three? Okay, two plus three equals five. Okay, free variable equals five minus two. Okay, so that's definitely true. That's the proof. Thank you for watching.